as was our learning goal last Friday when we did our first set of notes in this lesson, I can simplify and solve inequalities that contain variable terms on both sides. So we have to remember that when we have variable terms on both sides, there's more than one way to go to solve it. And somebody else might do a different first move than you do. But sometimes, and this is really important that we understand there's a difference between simplifying and solving. Sometimes you will need to simplify. So would you fill in the blank there that sometimes you look at it and you say, you know what, before I start solving this, I need to simplify. Sometimes you might only need to simplify one of the sides. Sometimes you might need to simplify both of the sides. Okay, so how do you know when you have to simplify? Well, here's the thing you're going to look for. If you have multiplication going on with parentheses, such as we do right here, and actually on the other side, or you have some like terms that can be combined on a side, then you know you have some simplifying you can do first. Okay, so what I want us to do first, though, before we do our simplifying, is I want us to change this subtraction, that any subtraction we have inside those parentheses, to add the opposite. So let's do that first. 5 times, in parentheses, 2 plus, what's the opposite of x?
Negative x.
Negative x. Is greater than or equal to 3 times, all we're doing is changing the subtractions to add the opposite. So x plus, instead of x minus 2, it's going to be x plus the opposite of 2, which is negative 2, yeah. Why do we do this? Because sometimes we're multiplying with negative numbers, and when we have negative numbers involved in subtraction, things go kind of awry for us because we don't really quite know how to handle it. So we're going to do, what's that property called that helps us do the multiplication over addition or subtraction? Anybody know what that property is called that we're going to do here? It's a long word that starts with D. Maisie? Yeah, we're going to do distributive property. Okay? So what we have to do is we have to take the 5 times the 2. So we have that multiplication. Plus, we have to take the 5 times the negative x. We have that multiplication. That will get rid of the parentheses. Is greater than or equal to. Now, you do not have to worry about in this step whether you're multiplying or dividing by a negative, because we are not solving. We are simplifying. So you do not have to worry about the negative multiplying or dividing. You just do it to get rid of the parentheses. We're simplifying. We'll worry about that later when we are solving. On the other side, we have to take 3 times each of the pieces x and the negative 2. So we have 2 multiplications on each side to do. Okay, what does the left side become? Seth, what's the left side become? 10 what? Okay, so we got to bring down the addition sign though in between, right? 10 plus a negative 5x is greater than or equal to. Remember, we don't worry about switching anything because we are just simplifying right now. 3 times x is, class, 3x. Bring down our addition sign. 3 times negative 2 is? Negative 6. Okay. What do you think? Do you think we're done simplifying? Remember, the other thing we would look for is, are there any like terms on the same side? So on the left side, are there any like terms that can be put together? 10 and negative 5x, are they like terms? Preston says no. You agree? How about the right side? Are there any like terms on the right side to be put together? No. So are we ready to solve? Yeah, we're ready to solve this. Okay, so I actually want you to put that in your notes. Ready to solve. We were simplifying before this. We are now finally ready to solve this. I'm going to put an arrow by it and say, you know what? Now this is what it would have looked like last Friday. They would have given me the problem already simplified. Okay, what's a good first move to make in this one?
You would add a positive 5x.
Okay, you could add a positive 5x to both sides. What's another first move we could make? What's another first move we could make? We could subtract 3x from both sides. Okay, so we just want to make sure that we know that you may make a different first move than somebody else, but we all should get the same solution. So we'll go with Adam's first call, which was add a positive 5x to both sides. A negative 5x is being added to 10, so we add its opposite. So now we have 10 by itself. What's the other side become? Blake?
10.
Okay, what's this side become? 8x plus negative 6. Okay, so the 3x plus 5x became 8x. Okay, now we all are going to make the same move. What's that going to be? Add 6, yeah. We're going to add 6 to both sides. We want those x's to be alone. So we add the opposite of negative 6, which is positive 6. And we should end up with 16 is greater than or equal to 8x. Finish it up. What are we going to do now? Divide both sides by 8. Thank you to the person that I heard say divide both sides by 8. $16 divided by 8, classes? 2. Do we divide by a negative?
No.
Nope, so we don't need to reverse the sign. Can we reverse the sign to make this friendlier?
Yeah.
Yeah, we have the choice of this becoming what?
X is
Yeah, so then we will more likely graph it correctly, right? X is less than or equal to 2. So what does the graph look like? Okay, go ahead and graph it. That was wrong. Make it very clear to you and to anybody else who reads your paper that is to include it in the solution region. Yep, how do we show that? Shaded in circle, and we make sure that we can tell that it's a shaded in circle. And then make sure it's very clear what other part of the number line is shaded, okay, including the arrow that belongs at that end of it. Okay, and then just do a quick check and say, you know what, the integer neighbor that's in the shaded region is 1. Is 1 less than 2?
Yeah.
Yeah, it is. So I'm feeling pretty good about my graph matching my solution at least. Okay, any questions on that one? Or we practice another? Okay, how about number 2? You ready to solve?
No, we need a
Simplify it? Well, how are we going to simplify this? What needs it? We need to do distributive property. Okay, well since we know we have to do distributive property and I see subtraction, I'm going to do the changing to add the opposite first before I even do the multiplying. Is there any distributive property to do on the other side?
no.
No. Are those like terms?
Yes.
Are 3 and
no.
3m like terms?
No.
No, one of them's got m attached, the other one doesn't. It's a constant, so they're not like terms. So now we will do our distributive property, which says take that 2 and multiply it times the m. Add to that the 2 multiplied times the negative 3. And everything else just drags along. Do we have to worry about the inequality symbol when we're doing distributive property? Do we have to worry about the inequality symbol, changing it, worrying about whether it should change or not when we're doing distributive property? No, only when we are solving, not when we're simplifying. So even though this doesn't happen to be getting multiplied by a negative 2 anyway, if it was getting multiplied by a negative 2 out here, we wouldn't have to worry about changing it because we're simplifying. Okay, so go ahead and finish this one up. Everybody solve it on their own because you know what. And I want your paper to show the steps. Everybody decide what moves you're going to make. We should still all end up with the same solution.
Okay, anybody make this first move? That's your first move?
Yes.
Okay. Anybody make a different first move? Maisie, what was your first move?
I subtracted 3 from both sides.
You subtracted 3 or 3m?
3 yeah,
The 3m, okay. So you're subtracting 3m from both sides, okay. So Blake, you made the same first move, okay. Anybody make a different first move yet from those two? Okay, good, because it's really a good idea to just deal with the fact that there's m's on both sides first, not worry about the constants. Sometimes students like to worry about the constants first, and then, kind of ends up making it maybe a little bit more confusing. So I'm just gonna finish it up with this way, and I'm gonna see what happens, and hopefully agree with those of you who use this way to solve, but then we also should all agree on the solution anyway. And then those of you who did it the other way, you're going to say to the people who did it this way, guess what happened when I did it my way? Okay, everybody get this solution? M is greater than -9.
Yes. Yeah.
Those of you who subtracted 2m from both sides, did it first start out, did it end up like this in the, like, I just wrote it the same way. Did it end up like this instead though? And then maybe you had to switch it around? Those of you who solved it by subtracting 2m first, did it end up like this? Hey, those of you who subtracted 2m from both sides, is this what happened? No? You're going to make me do it? Is this what happened? There's only 2 people who solved it this way. This one. The rest of you subtracted 2m from both sides. Should this have been what happened? And then you had to... Oh, you solved it that way? Oh, you just didn't raise your hand? Okay, gotcha. Did anybody solve it by subtracting 2m from both sides first? Yeah? Is this what happened? Yeah?
Yeah, I did it.
Yeah, okay. And then if you want to switch it around so it's friendlier for graphing, it ends up looking like ours. Okay, those of you who solved it by subtracting 2m from both sides first, do you have any sort of, like something you want to share with the people who subtracted 3m instead? Saying, you know what, this is what happens when you don't move the 3m, but instead you move the 2m. You don't want to share your wisdom? Okay. Okay, we should all have a graph that looks like... Do I have a good number line there? Do I have a good number line sense? Okay, that's always one thing I want to check out. Do I have an open or closed circle at -9? Open. Which way should I shade?
Right.
To the right is greater than -9, and then I want to check it out and say, is that integer neighbor -8? Does it make it true? Is -8 greater than -9? Yes. Is -9 less than -8? Yes. Is -9 less than -8? We leave it like this. This is how we would have to read it, wouldn't we? Okay. So let's go to the back side then. I think we're doing one more together. And it's because it has a decimal involved in it. Now, I know some of you maybe have, like you're so good at this, you've already worked ahead. I'm going to suggest something that you can do with decimal problems that will keep your fingers off your calculator. We're going to rename this, okay? Let's rename this. So in other words, then we can maybe not have to deal with, those decimals. So when I say rename this, what I want to do is I want to get rid of the decimal points. I want to move them so that I have whole numbers and not decimal numbers. So here's what we can do. As long as we do it to every piece, we can do this. If we move it over 1, that'll get rid of the decimal on that one. If we move it over 1, it will get rid of the decimal on that one. If we move it over 1, it'll get rid of the decimal on that one. Those are all the decimal ones. And just by moving it 1, we get rid of them. But we can't just move it in just those 3. We also have to do it to this one. Because what is moving the decimal one place to the right the same as? What are we really doing? I need you to process this. This is an important thing that you need to know. When you move the decimal point one place to the right, what are you really actually doing mathematically? That's just a pencil mark. What are you doing mathematically when you move the decimal one place to the right? When 3/10 becomes 3, what did you just do to that? Without even realizing it. You multiplied it by something. What did you multiply it by? 10. One place over, you multiplied it by 10. If you move it 2 places to the right, what did you multiply by? 100. If you move it 3 places, what did you multiply it by? 1,000. So we're renaming, and what we're really doing is we're saying we just want whole numbers. So we're going to multiply every piece by 10. And then we can work without our calculators. Makes it a lot easier. Okay, what would be a good first move in this one?
Minus 3x.
I agree. Take the 3x away from both sides. Did we have any simplifying to do? We forgot to ask ourselves that question. Was there any simplifying to do? No. No parentheses to get rid of, no like terms. We went right to work solving it after we renamed it. Okay, go ahead and finish solving that because I know that you know how. And I still am feeling confident that you can do this without your calculator. No, that you can't. You get to the point you have to ask yourself, how many 21s are in 63? 3, yeah, we don't need a calculator for that. 3 times 1 is 3, and 3 20s is 60, and 60 plus 3 is 63. So, did we need to switch the inequality symbol? Do we multiply or divide by a negative when we, no? So there's our algebraic solution, and we still need a graph representation of our solution. Okay, so today you need to, in the problems that you're working, you need to keep it straight. What's the difference between simplifying and solving? When do I need to simplify first? When can I do something like this, rename the equation to make it a nicer look to work with? Anybody have any questions at all?